Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We've been talking about inheritance, looking at how it can provide us with inclusion polymorphism, and a number of the details for how we control things in the program for when subtypes have to override things, when they aren't allowed to override things, and basically trying to set up a good system using the inheritance. Now, it's worth asking the question of when should you inherit and when should you not. I said previously that inheritance represents an is-a relationship. So in the case of our shapes, a rectangle is a shape and a circle is a shape. And the general rule that you probably should follow pretty exclusively is if you cannot say something like that, you should not use inheritance. However, the flip side of the coin is the question, well, what if you can say that? Does that automatically mean that you should use inheritance? And to help demonstrate whether or not that is true, we can actually extend further upon this. So we have our shape and our circle and our rectangle. And what if I want to add a square? Well, going back to your math class, you know that all squares are rectangles, but not all rectangles are squares. So you can say a square is a rectangle. Based off of that view, it's tempting, let's scale this down a little bit, it's tempting to put our square down here and have it inherit from rectangle. And so at least temporarily I'll come in and I'll put this in here. I'll put in a square with no data in there currently. And I could make it so that this inherits from rectangle. Okay. What would that look like in the code? And is this an ideal way to do things? So if we go to Eclipse, I can make a new class. So we'll make a new Scala class. I'll call it square. Now the square is only going to take one parameter plus the color for that's associated with all shapes. The square takes a single length, which is a double, and the color. And it extends, at least in the way that we have it in our diagram, a rectangle that has both width and height of length, and then C is the color. And if I import color, what are we? Oh, that's right. At the end of the last video I had made rectangle final, which because it's immutable might actually be a good idea. But for this example, in order to illustrate this, I have to make it so it's not final. Okay, so this would actually be a complete implementation of my square. What are the benefits of this? In fact, because it is complete, I can even do that at this point. There might wind up being some other methods that I would want to put in there later, but this square is really simple. And that's the primary benefit, is that it is utilizing the code that we have in our rectangle, and whatever other code we might put in our rectangle would work just fine for the square. I do have one minor discomfort with this, which is the fact that our rectangle is actually storing two doubles, a width and a height, and the square really only needs to store one. Now notice I didn't make length a val. So the square isn't actually storing the length, it's just passing the length through to the rectangle, and it's keeping track of both of these. This works. I won't say it's necessarily ideal. In this case it works fairly well because I didn't have to rewrite these three methods. And had there been a lot more methods in here, that might have even been a better idea. But there still might be a superior approach where I create some type of a class for a parallelepiped or whatnot, and put it above both rectangle and square. That way the square could only store one double while the rectangle stores two. And then maybe there would be some other functions that would differ. Now I want to do something that's slightly different. I'm going to throw in another rectangle here. And I am going to call this my M rectangle, M for mutable. So the mutable rectangle needs a width and a height. For the UML, because I don't really care too much, I am going to go ahead and say that these are public. I'm not actually going to make them public. I'm going to use the accessor methods that we've talked about. I'm going to put in some private vars, and then I'm going to give public access to it. And then, of course, we need to have all of our other methods. I will come over here and copy those so that I don't have to retype them. Okay, and now we can make a connection to this class that is an extends style connection. There we go. Let's go ahead and let's write the code for that. So I'm going to make a new Scala class. I'm going to call it mRectangle. My mRectangle extends shape. We will need an argument that is color coming in here. The rectangle needs a width and a height, so I'm going to make a private var L width, L for local, and a private var L height, oops, colon, double, colon, double. This is just long enough that I'm going to break it up across multiple lines. Okay. Oops, need to maximize that. I will copy the methods from my other rectangle, which won't work quite yet. So these are private vars, and I'm going to add some public methods to get them. So width just returns L width, and height just returns L height. And then because I'm going to allow them to be mutable, I want width underscore equals W is a double, and this is L width equals W. Height underscore equals H is a double, L height equals H. And import so that we get that graphics 2D, import again so we get the rectangle, and there we go. Okay, so now I have a perfectly valid mutable rectangle. And in fact, we could come into our, close that and close that. We could come into our shape class and val r2 equals new mRectangle of 20, 30, color dot black. I prefer the lowercase version. And I could call print shape with it. I could have it draw. It would work nicely. The advantage that you have with the mutable, advantage in quotes here, the extra capability that you have is that I can do something like this. And I can change the width of my rectangle. Okay. And so there are clearly applications where that type of flexibility can be useful. Now let's go back to our diagram here, and let's think about the situation of having a mutable square. Okay, well, it would make sense in this diagram, since I had square inherit from rectangle, to create a mutable square and have it inherit from mutable rectangle. Okay, and I'll skip filling things in. And we should look at what code we have to do in order to make this so that it works nicely. So if I go back here to our code and I decide to put in a new Scala class of m square, I want the m square to have, well, let's see, I'm going to go with, I'm using the values from the rectangle, so length is a double, c is a color, extends m rectangle of length comma c. Let's import the color. And at this point, I have a, quote, working mutable square. Working's in quotes here because let's see what happens if I make one of these. There we go. S is an m square, and m square just takes one length. That's all perfectly happy. S is a square. However, what happens after that line of code? Now I have this thing S, which is supposed to be a square, but it's now an 80 by 30 square. Well, that's not a square. Okay, so there are basically two ways of fixing this. One, the bad way, the way we shouldn't do it, is to go into square and say, you know what, you're not supposed to be able to, if you change the width, you're also supposed to change the height. So how about I override def width underscore equals, pass in a w, and I'm going to say super dot width equals w, super dot height equals w. And then I'm going to do the same thing for the height. And I'll leave it as a w because it's setting both the width and height. Now, when I change the width of my square, the height changes as well. So at least we're preserving the fact that this is a square. On the other hand, we've kind of violated the agreement of what happens with a rectangle. So if I write a function that takes an m rectangle as an argument, and that function sets just the width, the idea was that only set the width, it didn't set the height as well. But because m square is a subtype of m rectangle, you can pass in an m square, and now when the function sets the width, both the width and the height will be set. And so this is a bit problematic. And really what's the proper solution to this is to say, no. We should do that instead. Okay, that's the proper solution. This is a situation where using inheritance is not ideal. Even though a square is a rectangle, this situation where they are mutable is definitely the wrong way to go. Okay. When it is immutable, You could consider doing that, though quite honestly, I would feel much better if we were to change this up and have square go directly from shape, if for no other reason than that way I can make my rectangle final. Having inheritance hierarchies that go multiple levels deep turns out to be a risky proposition. Things get brittle that way. You're much better off having just 2 levels in your inheritance hierarchy, where you have some abstract type here and some concrete type here. Maybe you can go to a 3rd level if you have a really good reason to. In this case, I don't have a really good reason to. I don't feel like there was a huge benefit to either one of these. And as I said, even here where it's immutable, having the square inherit from the rectangle had 2 costs to it. 1, I couldn't make the rectangle final, and 2, the square started containing 2 different doubles when it only needed to know 1. So I would argue that this is a situation where I don't want to use inheritance, even though I can say that one type is a subtype of another. Just because you can say that it's that it follows the is a relation, just because you can say that it is a subtype in a formal definition sense, does not mean that it should inherit from it. And that is especially the case if you have methods that should not be part of the subtype. And in the case of our m-square inherited methods to set, width, and height. So if we come over here, the real problem with m-square is the fact that by default it inherited these 2 methods right here. And those 2 methods do not belong in a square. They are not valid things to do to a square. You cannot independently set the width and the height. And that is what those methods are supposed to be doing. And since those 2 methods, while they are just perfectly fine and happy for a rectangle, because they are not perfectly fine and happy for a square, really, you should not do this. You should not make the square inherit from the rectangle. You should flatten out the inheritance hierarchy and make the square inherit directly from shape instead of going through the rectangle. You might have to re-implement a few things inside of the square, but you won't have to override things, and you will have created a structure that is more logically sound. So that's it for this video, and we'll see you again soon.